Day 11. Today we'll talk about the optimizer. So previously we have run the OpenFOAM CFD analysis. We've got multiple coefficient of drag values, but there are just too many parameters that we need to change in our range. So today we talk about the optimizer itself. The optimizer that we're using today, it's called Dakota. Dakota was developed by the Sandia Labs. The idea essentially is you want to reduce your design space to a lower limit to an upper limit between which you'll find your optimal, results of your coefficient of drag. So today we'll just discuss what this Dakota is, how you can get it, and what is this input file that we're talking about. So the first thing that we're talking about here today is the Dakota input file, the .in. This is what Dakota takes. There are 4 different design variables that we are giving essentially. That's the length, width, head size, and the angle. If we wish to, we can increase these, but for the initial, we are still just running with 4. Then there is the method here. Method, the con-min FRCG. This stands for Constrained Minimization Fletcher-Reeves Conjugate Gradient. This is a local optimization algorithm. It assumes that there is a smooth valley and tries to find the bottom, minimum drag by following the slope downwards. Next, we have the variables. These are our knobs essentially. So for x1 meaning the length, x2 meaning the width, and so on and so forth. We have our own lower and upper bounds essentially. Then we have the interface. In here, this is the driving script. This is what will run everything for us essentially. Now, the way it works is OpenFOAM is coupled with Dakota. OpenFOAM will give the results of CD. This CD value will go into the optimizer. Optimizer will understand for the given variables that we have here, the value if it is higher or lower compared to a previous iteration. And based on that, it will choose what value to reduce or what value to increase for our variables. So that's that. And that is controlled through the parameters.in file right here. And Dakota will spit out the results through the results.out file right here. And everything else, that we have, essentially this is for cleanup. We're just writing everything that we want essentially in the proper fashion. There are a few things, that are present here. There is something called the responses. The objective functions is equal to 1 essentially means that you're optimizing for just one single thing here, which is drag, and its description is present right here. Now, we don't have to calculate the mathematical derivative of this particular drag, meaning that we don't have any gradients, and we also don't have any Hessians in that sense itself. So for every iteration, Dakota will essentially run simulation roughly 7 times. So one base run, one perturbation run for each of 6 variables to figure out which direction is essentially your downhill or where your CD is the minimum. So that's pretty much about what this input file talks about. The way in which we will interface with this is going to be the script here. So on the topic of how can you actually install Dakota, I have the website just present right here. This is dakota.sandia.gov. Major way in which you want to do it is through Python. The essence of why that is because, as you've seen, Python is quite scriptable, and you can install Dakota on a virtual environment or a particular set of environment, however you want to do it. The way I do it is through Miniconda or an instance of Anaconda, in which I create a separate environment for both Dakota and my FreeCAD, so both of them can interface, and you have your design optimization loop closed. So Python separately works along with OpenFOAM. Within Python, you have your Dakota and your FreeCAD all combined together. So the way you can do the installation is you go to downloads, and there are a bunch of options available for you. So you can install this from GitHub, or you can come back here and click on the user's manual to essentially reach right here. And here you can download the Dakota version however you want to do it. If you want to download it from here, you'll have to Include this in your path so that you can call Dakota from anywhere in your folders. If that feels too difficult for you, then just do the Conda installation. So as you can see here, the Anaconda website, there is the Dakota. You have the Conda install, Conda Forge with the Dakota. And in a sense, what you want to do is, again, create a virtual environment or a separate environment for yourself, and then install this as well as FreeCAD. Both of these will work together. My installation uses Python version 3.11, if I'm not wrong. So test for yourself. Now that we have a good idea of what the optimizer is, what inputs we are giving to it, we'll just let this run and come back tomorrow and understand what our optimizer has spit out for us. So see you tomorrow.